Hello, good evening, everyone. This is your algebra test review for Mr. Swenson's class, whether you're in Mr. Swenson's class with Ms. Murdoch, or you're in Mr. Swenson's class with myself, or you're in Mr. Swenson's fifth period class. This is your review. I'm going to go through. As you can see, the screen already has the answers, so just understand and realize the answers are already there in case you want to follow along. I'm also going to be doing the work on the side, and I'll tell you if you have any questions, what you can do. All right. So let's look at question number 1. Okay. So the expression 5x to the 9th power divided by 10x to the 3rd power can be simplified to. So guys, this is a simplification question. So again, remember when you have exponents, and it's just the rule. You're multiplying, you're really adding them. Okay, you're really adding them. So just to be clear, when you multiply exponents, you're really adding them. The same is true for the opposite. So when you're dividing exponents, you are really subtracting them. Okay. So with that being said, and again, if you know all this is great. You should get 100 on the test tomorrow. Knowing all that, and again, the work is on the side. So again, if you want to follow along, the work is here. Okay. So knowing that, we're going to answer this question. So this first part is 5 divided by 10. You cannot divide 5 by 10. You can, but it's going to give you a decimal. Okay. So in this case, we simply simplify. You simplify by division. You know that this goes like this, and you get 1/2. Okay. If you're struggling with simplification, you can use the calculator. So again, you'll turn your calculator on. I'll show you if my calculator opens up. And I'll show you that process, I guess, when that opens anyway. With the exponents, you have your x. You have your x to the 9th over x to the 3rd. So you're really, again, subtracting. So this is going to be x 9 minus 3. And you're going to get x to the 6th power. Okay. So you have x to the 6th power, which goes here. So that's why your answer is going to be choice number 2. Okay. Again, just to be clear, because you have 5 over 10, you have to simplify that. If it was the reverse, then you would divide. Okay. All right, moving on. Question number 2. Okay. Which of the following is equivalent to 2 to the negative 3rd power? So again, which is equivalent to 2 to the negative 3rd power? Just remember this, guys. You cannot have negative exponents. You can, but we don't like to leave them in negative. So we kind of have to change this, okay? In order to change this, we have to make a positive, but now it goes to the bottom. And then when it goes to the bottom, it becomes positive, okay? On the top, what do you have? You're left with the 1. So anytime you have a negative exponent, you move it to the bottom, it becomes positive. Now, we're not done because you can do 2 to the 3rd power, which is 2 times 2 times 2. So I have the 1 on top. 2 times 2 is 4. 4 times 2 is 8. So you're going to have 1 over 8. Okay, your answer is going to be 4. Again, if you have a negative exponent, so I'll just give you another example. If I have 4 to the negative 2nd power, it has to go to the bottom and it becomes positive. And I have my 1 here. Okay, and then 4 squared is 16. So just again, your negative has to go to the bottom. Okay. Question number 3. If f of x equals 10 times 2 to the x power, then which of the following represents the value of f of 0? It's pretty simple. We have a 0 here. What that simply means is wherever we have an x, we're going to put a 0. So again, and again, I apologize for the noise. I'm using my finger to write, so if things come up properly, we should be okay. So wherever I have an x, I'm going to put a 0. Wherever I have an x, I'm going to put a 0. Okay. So what this question simply is saying is, because I'm solving for f of 0, that's all I simply have to do. Now, f of 0 equals 2 to the 0 power. Now this is a fun one, and I know Mr. Swenson talked about this in class, but 2 to the 0 power actually equals 1, not 0. Anything to the 0 power is equal to 1. So if I have 10 to the 0 power, equals 1. If I have 100 to the 0 power, it equals 1. Whatever, if I have negative 1 to the 0 power, it equals 1. Okay? So f of 0 is 10 times 1, which is simply 10. So my choice here is going to be 3. Okay? Please remember, anything to the 0 power is 1. Okay. Question number 4. Which of the following is the equation of an increase in exponential function? Okay, first couple of things. We have to understand what's an exponential function. An exponential function clearly is going to be dealing with exponents. So we can eliminate 3, because that's not an exponential function. That's a linear function. Okay. That is linear. Okay. Now, we have to be careful because the others do have exponents. But choice 4 is not exponential. That is quadratic. So now we have 1 and 3. Those are both exponential functions, but the key word in this question is increasing. We want to know when is it going up. So as you learned in class, anytime it's going up, it's going to be plus 1. So we have to look at anything being plus 1. So any percent being plus 1. So meaning an increase in 1 has to simply be above 1. So that now eliminates choice 3 because choice 3 is below the number 1. And this actually is decreasing. Because again, increasing is plus 1, decreasing is minus 1. Okay. So my choice is going to be 2. And how do you know it's over 1? You simply do 3 divided by 2. Okay. Once you do 3 divided by 2, you'll see your answer and you'll realize that, okay, that's the answer. Okay. Questions, concerns, again, read the question, circle the keywords, because again, the keywords will indicate to you what it is doing. Okay. Question number 5. If Jordan has his hourly salary increased from $9.25 per hour to $10.75 per hour, which of the following is the closest? Remember the word closest to the percent increase in Jordan's salary. Now, percent increase is clearly talking about a percentage. So what I'm going to know is something's going to increase or something's going to decrease. Okay. So in order to do percent increase, and again, it's here, just if you're still struggling with that, I'm going to take my highest salary. I'm going to subtract. Even though it says increase, I'm still subtracting because we're still learning the difference. It's kind of, we're trying to figure out what the difference is. Okay. So that is the key. Even though it says percent increase, we are still subtracting because we want to find the difference in money. Okay. If it said percent decrease, you still be doing the same thing. So this is that one question where percent increase and decrease, you're still trying to find that difference. So once you subtract that, you get your 150. Now it's over your starting amount. So what do you start with? Your starting amount is going to be the $9.25. Okay. Once you divide that, you're going to get a decimal. You're going to get 0.162. But again, we're not asking for the decimal. We're asking for the percent. So when you go from percent to decimals, you divide by 100. So this is going to be opposite. You're going to times by 100. Okay. And then your answer is going to be 16.2, which if I look at closest, it has to be 16. If you're struggling with this question, look over it again. And you can actually probably make up a question. You can say, I started out with $5. My pay increased to $8. You can do the same process. It will be 8 minus 5 divided by 5. Okay, so that's a question that you just kind of have to know. Okay, which of the following could be the equation of the exponential function shown below? So the first thing I'm going to look and make sure these are all exponential functions, and they all are exponential functions. So I can't cancel out looking at that. Second thing I'm going to look at, and Mr. Swenson in the answer key has it, this is decreasing. So if it's decreasing, it's going to be below 1. Remember, decreasing means below 1. Okay. So I'm going to look at the ones that are below 1. I'm going to say, you know what? That's below 1, so this could be an answer. Let me see. This is below 1. This could be an answer. And these other two are not. Okay. How do I know it's decreasing? Because you're not going to have this thing. Look at the graph. It's going down. So that's how you know it's decreasing. You know it's decreasing because when you look at the function, it's going down. Okay. Now, my next step is, okay, well, how can I really tell if it's 1 or 3? Well, it's pretty simple. Your next step, you're going to look at the starting point. You find that starting point looking at the y, and where it starts on the y. Okay. So I'm going to remove that for a second so we can kind of see. It starts, and again, this is a little bit more general, okay? And remember, the question says could be. So it's probably right about here, okay? What number is that? Clearly it's not 3 because 3 would be somewhere down here. So you know my answer is now choice 3, which is 8. Okay, so again, first step, look at the function is going down. If it's going down, it has to be below 1. So it can't be 2, it can't be 4. Look at my other choices and look at where it starts. It starts at right around here, so that has to be 8 and not 3. So that's what my choice is. Okay. Question 7. The population of Ketchum High School has decreased by 5%. The population is currently 2,600 students. Which of the following is closest to its population 2 years from now? So we talked about it. It gives you keys. This is decreased by 5%. Okay. So now I want to know what is the population 2 years from now. So it tells you your starting amount. My starting amount is 2,600. Okay. It's decreasing by 5%. So I know if it's decreasing by 5%, I know I'm going to have to subtract. Okay. We talked about this in class. The easiest thing to do is change this percent into a decimal. So again, you can divide by 100, or you can move the decimal. So my decimal's there because this is 5. I'm going to move it twice. And now my decimal's there. And now I have 0.05. So that's how we got the 0.05. Okay. And I want to know, so again, my initial starting, I started with 2,600. I want to know what I'm going to have in 2 years. So that's where I got my 2 from. Okay. So again, starting amount, 2,600. Because it's decreasing, I know I'm going to subtract from 1. A lot of you guys missed the 1, don't miss the 1. And I know it's 5%, so I'm going to divide that by 100. I'm going to go to 0.05. Once you do the work, you're going to get this answer. And clearly, we just rounded up. We took the 5. The 5 goes up. 6 turns into a 7. My answer is going to be 2. Okay. Again, we practice this. We're going to get several questions like this. Remember, you have your growth factor. You have your decay factor. In this case, because it's decreasing, it's your decay factor. Question number 8. The population of bacteria is increasing at a rate of 7.5% per hour. If there were originally 275 bacteria, which of the following equation models the population of bacteria at H hours after the original 275 bacteria were measured? So I want to know again. It's increasing. So my keywords in this is increasing. I have my rate, which is 7.5. I have my original amount. So again, it's real similar to the last question. We have our starting amount. Right? Because it's increasing, I know that I'm going to be adding 1. And again, I'm going to take my percent. So 7.5. I can either divide it by 100, or again, since my decimal's here, I can move it over twice. So I'm going to move it over twice, and that is my decimal. Okay. Once I add that up, I get my answer, which is 4. Okay. So just remember the key words. Increase, you're adding. Decrease, you're subtracting. Okay. If the first 2 terms of a geometric sequence are 4 and 12, which of the following would be the 10th term? Okay. So I'm going to read what it says. Geometric series increase or decrease by a constant multiple. In this case, the common multiplier is 3. Well, how can you tell it's 3? My first number is 4, my second number is 12. I know that it's increasing by 3. Okay. I know it's increasing by 3. How do I know it's increasing by 3? Because 4 times 3 is 12. Or if you forgot, you take your second number and you divide it by your first. Okay. So now, some people, if you want, you can do 4, 12, you can keep going times 3, then you keep going times 3, and you can really get your number doing that. But if tomorrow's exam said, what is the 100th term, you would be in trouble. So please be careful with that, okay? So now, just create your rate, create your change. We talked about this in class. In order to solve for the number before, you need the previous number. So we have our 10th term is going to equal our starting amount times our change, right? We talked about this. And in this case, it's to the 9th power. Why? Because you need the 9th number in order to solve for the 10th one. Okay. You do all that, you get this. Okay. All right. Question number 10. This is actually a Regents question. If I think back to it, this is pretty similar to a Regents question they gave a couple years ago. This does involve several steps, so just follow along. A radioactive material has a mass given by m of t equals 126 times 0.84 to the t power, where the mass is in grams and the time t is in years. It says, which of the following gives the average rate of change of the mass over the intervals 2 less than or equal to t, which is less than or equal to 5 years? Okay, so how do we figure this out? We got 5, we got 2. So guys, it's simple. This is a rate of change question. Okay, rate of change meaning we have to kind of solve. So t is our time. So we have two things. We have t is 2 and t is 5. So we simply, for the first one, plugged it in. So we have m of t. Let's scroll back up to the formula. It's 126 times 0.84 to the t. So all we simply do, we replace t with 2 to get our first answer. Replace this with 2. And then for our second answer, we replace it with 5. Okay. So when we did 2, we got one answer. Okay, we got 88.9056. When we did 5, we got 52,000.6947. Now, here's a key to this question. There's one vocabulary word that tells you you have to do the rate of change. That vocabulary word is average rate of change. Okay, and if you remember average rate of change, and we talked about average rate of change, it is going to be the change over the years. Okay, the change over the years. So what does that mean? That means at 2 years, I had 88.9056. That was my first coordinate. At 5, I had 52.6947. So average rate of change simply means the change in y over the change in x. So if this is my x, 1, this is my y, 1, this is my x, 2, this is my y, 2, and I simply do my formula. And again, just to remember, if you remember the formula, y2 minus y1 over x2 minus x1. So again, my advice in this question is just look at the steps. Look at what they're asking you for. They gave you specific things, and then they ask you for the average rate of change. Okay, so take the information, solve for the 2, solve for the 5, and then do the average rate of change. Okay. And again, I'm sorry, I scribbled all over this question, but just to be clear, because the question asks you for the average rate of change, that's how you're answering this question. Okay. All right, moving on. And again, guys, at any time, if you feel you're confident you got this, then move on. You can always skip through the video. All right, but I do want to speed this video up because I don't want this video to be an hour. Again, when you divide fractions, you are really subtracting them. Do not forget that when you divide fractions, you're really subtracting them. So you're really doing 5 minus 9. Now, it's okay. You can have negative exponents, but you got to simplify them. 5 minus 9 is negative 4. If you put negative 4 in the test, you're going to lose points. If you put x to the negative 4 power, you're going to lose points. It is wrong because you cannot have a negative as your answer. Remember, you have to move it to the bottom, make it positive, and then you put the 1 on top. Okay. The rule, if it's negative on top, move it to the bottom. If it's negative on the bottom, you move it to the top. Question 12. Okay. In class today, we kind of struggled a little bit with this question just because we have to be clear on what our multiplication is saying. Okay. This exponent, and I'll write it big so we can kind of do it. 3x to the third to the second. Okay. What this is saying is you have to take this exponent and go to both of them. Not just this one, to both of them. So what this is really saying is 3 squared times x to the third to the second. That's what this is really saying. Okay. Once you do that, 3 squared is 9. X to the third to the second, because remember, these are together now, you multiply. So that's the only time you multiply exponents, when they're kind of together. Okay. So we have 9x to the 6. Okay. Second thing, a mistake that I do not want to see you guys make tomorrow. 6 times 2 is 12. X times x. Guys, x times x. You've done it before. That's a 1. That's a 1. It becomes x squared. It becomes x squared. So again, there goes your square. Now you simplify. So unfortunately my calculator is not coming up, but you can simplify 9 over 12 and you get 3 over 4. Okay? X to the 6 divided by x to the second. Remember, you're again subtracting. You're going to get x to the 4th. And that is your answer. Okay. An object's speed can be modeled with the equation s equals 24 parentheses 1.06 to the t, where s represents the speed in miles per hour and t represents the amount of time that's passed in seconds. Give an interpretation of the parameters 24 and 1.06 from the equation. So they're just simply asking you what the 24 is and what's the 1.06. Okay? So we know the 24, okay, is our starting amount. Okay? Meaning, if it says speed, we're simply saying, and again, the explanation is there, the object was moving 24 miles per hour. Okay? That's how fast it was moving. Okay? The 1.06, or if we talked about what it is, this can also be considered our starting amount. Okay? Mr. Swenson mentioned yesterday about calling the y-intercept as well. I mean, technically it is the y-intercept because that's where you're starting. You're starting at the y. The 1.06. Now, we have different names for this. This is our growth factor because it's growing. Again, we talked about if it's over 1, this is our growth factor. But we can also interpret it a different way because if we look at this decimal, we can also determine it to be that it increased by 6%. Why increase? Because again, it's above 1. And if we change that decimal back into percent, going the other way, it's going to be 6%. Okay. Either way would be acceptable in terms of what this means. Okay. Okay. An exponential function f is shown at the table below. Determine an equation for it in f of x equals a times b to the x power form. So, we talked about it 2 seconds ago about our a value being the y-intercept, meaning where does it start? So in order to find the y-intercept, you have to make x 0. So if x is 0, and again, remember f of x is also y, we know that our y-intercept is 13, which is our starting spot. Okay. Again, how do you know? Because the 0 is there. Now I have to look at how does it increase? How can we tell? We can tell because we look at the two numbers. We'll look at the 39 and we'll look at the 13. If you're struggling with multiplication to figure out what it is, take the second number, divide it by the first number. Why are you dividing? Because you're going backwards, because this is an exponential function. If you divide it, you're going to get this being 3. Okay. And again, it's just an exponential function. We're not asking you to solve anything. We just want you to write an equation. We're going to put our x here. And because it's a function, don't forget the f of x. And this f of x simply says that if I make x any number, this is the equation that I would use to solve this question. If you want to check it, you can type this in a calculator and check it and see if the tables match up. Question 15. Max deposits money into a savings account that earns 3.5% interest applied annually. If Max initially deposits $450 into the account, how much money does the account hold after 5 years? If Max does not deposit or withdraw any additional money, show how you arrived at your answer. Okay, so again, we've done this question several times. It's worded a little bit differently. It's not necessarily saying increase or decrease. So what is my keyword here? My keyword is going to be interest. Interest means growing. When you have interest, your money is growing. So I know that it's going to be plus in a parentheses. So I know based on the word interest is going to be plus 1. Starting amount is 450. My growth factor is 3.5, but again, it has to be a decimal. Now don't be confused. It looks like a decimal, but it's still a percent because of the percent sign. So you still got to divide it by 100 or move it over twice. So it's just going to be 0.035. If there's a percent there, it is not a decimal, it is a percent. You have to change it into a full decimal without the percent sign. You do that by dividing by 100 or moving the decimal, okay? Now, what's missing is how much am I going to have after 5 years? So that's my time, okay? Once you do the math, you're going to get that answer, okay? Pretty simple step. Everyone should get this right. Just don't confuse yourself if you see a decimal in the percent. It's still considered a percent until you move it over twice or you divide by 100. Okay. Determine the equation of the exponential function shown graph below. Explain how you arrive at your answer. Okay. So it says I have a graph. So again, the first step, the first way I will tackle that question is I'm going to look for the word touches y, because that will tell me my starting amount or my y-intercept. So I'm going to look and I realize it touches y right there. Okay. So now I know that it touches y at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now, oh, this is 1. Sorry, I miscounted. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I know my starting amount is going to be 10. Okay. That's how I know where my start. Now, how do I find my growth, or in this case, it's not a growth rate because it's going down, my decay? I'm going to plot some points. So now I know that is, my first point was 0, 10. I'm going to go to 1. My next point is going to be 1, 5. So if I create a chart, I have 0, 10. I have 1, 5. And then if I go to 2, it's like in the middle. So let's say 2.5. Okay. How do I find my percent? Again, we just talked about it in the question. I'm going to take my second number divided by my first number. 5 divided by 10 is 1/2. I simplified it. Now, you could divide 5 and 10 and get 0.5, which is your other decimal, and then you have your time. So how do you tackle this question again? Look for the y-intercept. After you look for the y-intercept, look at some points. So 0, 10, 1, 5, 2, 2.5, excuse me. You have your growth factor, in this case your decay factor, because it is going down. Okay. Question 17. A function passes through the point 0, 8 and 1, 24. write an equation of a linear function that passes through these 2 points, and write the equation of an exponential function that passes through these 2 points. So it's a tricky question because they ask you to do 2 things. Okay, linear, you have y equals mx plus b. Exponential, you have y equals a times b to the x power. Now, how do you find that b equals 8? I said the same thing. In order to find the y-intercept, x has to be 0. If x is 0, you have your y-intercept. Okay? Because x is 0 right here, we know our y-intercept is 8. Based on the fact that we know our y-intercept is 8, and if you remember back, our y-intercept is going to be b. We know we're going to have y equals something x plus 8. We don't know m just yet. How do we find m? We talked about this. You know this. You should got to memorize this formula. We have a formula for m. M is y2 minus y1 over x2 minus x1. That is our m. We do the work. We're going to get 16. We'll replace this now with 16. We get 16x. Okay. Similar thing, but a little bit different because you kind of have to multiply. So again, same idea. The y-intercept is 8. How do you know? Because we just said it. In order to find the y-intercept, x has to be 0. So we know that the y-intercept is 8. So we know y-intercept is going to be 8. How do I find 3? I take the second number, divided by the first number. Voila, I have 3. And do not forget the x because it's to the x power because it's an exponential thing. Okay. So now they want to know how much greater is the exponential function valued at x equals 5 than the linear function value. So it's pretty simple. All you simply do, it says x equals 5. You replace x with 5, you get your answer. So x is 5 here, you get 88. You put the x to the 5th power here, you get 194. Difference, guys, difference. This is difference, right? How much greater? Meaning you have to subtract. If this is this, and this is this, the difference meaning you have to subtract. Okay. Geometric sequence is defined using the following rule. F of 0 equals 4, and f of n equals f parentheses n minus 1 times negative 2. Looking for the 4th term. It's simple. We're looking for the 4th term. We have to do this in order. So I'm going to do the first one just to show you what it looks like. So I have f of 0. Now I'm going to look for f of 1. Meaning anywhere I have an n, I'm going to put 1. So this is going to be, instead of n, I'm going to put 1 minus 1 times negative 2. 1 minus 1 is 0, so I have f of 0 times negative 2. F of 0. Man, what's f of 0? Oh, snap, it's up here. F of 0 is 4. So this is 4 times negative 2. So 4 times negative 2 means f of 1 equals negative 8. I'm going to follow the same process again. F of 2, right? I'm not going to do the whole thing. I'll just show you. F of 2 equals, instead of n, I'm going to put 2. 2 minus 1 is 1. F of 1 is, oh, what's f of 1 again? Oh, snap, f of 1 is negative 8. So I'm going to have my negative 8 times negative 2. Negative times a negative is a positive, okay? And that's how you figure it out. You do it 2 more times, you'll get your 4th term. Which is larger, the 10th term of an arithmetic sequence that begins with the term 0 and 100, or the 10th term of a geometric sequence that begins with the term 5 and 10? Show work that justifies your answer. Whoa, that just went over our head because it was a lot of words. So you have to break this down. Which is larger, the 10th term of an arithmetic sequence that begins with the term 0 and 100? So for the first 2 terms of an arithmetic sequence, we could tell we need to add 100 to get each term. So the 10th term would be this. Okay, arithmetic sequence. What do we do arithmetic sequence? We add. Does that make sense, guys? We add. For geometric sequence, the first 2 terms, we can tell we need to multiply by 2 to get each term. So I begin with terms 5, and then I go to 10. So from 5 to 10, what operation did I do? I did times 2. Does that make sense? So I started with 5. I times it by 2. Sorry, that didn't come out. Let me just write that clearer so we can see that one. So again, I started with 5. Did times 2. What term am I looking for? I'm looking for the 10th term. I'm looking for the 10th term. So if I'm looking for A10, I can't use 10. I have to use 9. If I'm looking for A9, what term would I have to use? I'd have to use 8. Okay? So, based on this, I get that answer. Okay? So, who has the largest 10th term? Clearly, the one with the largest 10th term will be this geometric sequence. Okay? Question. Okay, and again, for here, just to be clear, if I was a little unclear, we're starting with 0, right? I go to 100, meaning that it goes up by 100. And I'm looking for the 9th term, so that's why it's times 9. 10th term, and again, we just talked about it's times 9. Okay. Question 20. And again, if you got this, if you feel like you got questions, you can skip the video. I want to get through this because it is going a little long. Let's see, we got one. Oh, last question. Oh, I lied. I think we got 2 more questions. Okay. A local newspaper claims that the number of flu cases increased exponentially, meaning that there's some type of exponent there. On Monday, there were 8 cases of the flu. On Tuesday, there were 12 cases. On Wednesday, there were 24 cases. On Thursday, there were 30 cases. Was the newspaper claim an exponential increase accurate? Justify your response. So, they said, we start out with 8. Then we went to 12. Then we went to 24. And then we went to 30. In order to do exponential, they have to be multiplied by the same number. Okay. Well, clearly, we can tell they're not multiplied by the same number. So, no. But how do you show your work on it? Again, simple. Take the second number, divide it by the first number. You do that division, you get this. I'll take the next number, 24, divide that by 12. I'm going to get this. Keyword is constant. It is not constant. And because it's not constant, it is not a ratio. It's not exponential. Okay, the ratio is not constant. Not constant. So that will be your answer, and your work will be here. Okay. Last question. The first 3 terms of geometric sequence are shown below. Write a recursive rule for this sequence. So we're kind of going a little bit backwards. Now, the first thing you need for a recursive rule is the first number. The first number is what? If I look at the first number, it's going to be my first number, which is 216. Okay? So, based on the fact that I know it is 216, I'm now going to do the same rule we have talked about. Okay? It says we need to determine the constant multiplier or ratio for this geometric sequence. We need to be careful because it's a decreasing exponential, meaning it's going down. So, again, take the second number, divide it by the first number. When you divide, you're going to get your answer. Okay? Questions? Okay. So now we have our rate of change. Okay? Guys, it says what's the next term in the sequence? So again, you do the same work, you do the same operation, and that's what you guys are going to get. Okay? Questions? Concerns? Now, if you're still struggling with this, you can email me. You could definitely email Mr. Swenson. You can email Ms. Murdoch. Guys, have a good night studying. Take care. Stay out of trouble.